All right, class, so Hugo, with a review for trig. So let me pull up your review. I have several reviews that I've given you recently, so bear with me. This should be the first one. That's not. It's not that one. It's not this one. Let me take a look at this one. Same concepts. I think it's this one. Yeah, this is the one that we've been working on. So let's take a look at the solution steps. I'll start with the first 10, like I said, on the first screen. And I am going to use my own personal online calculator to work with you through the questions. So question number 1 with the car wheel, anything that is giving you the radius and the arc length, like this one, they're telling you the radius is 16 inches. So that tells me that whatever they give you the arc length as, you need to switch it so it's inches also. So if this is 5 feet, we're going to multiply this by 12 inches. And therefore, this is now 60 inches. And the formula we're using is that theta in radians should be equal to R over S. So in our case, we're going to take 60 inches, and we're going to divide it by 16 inches. So this value over this value. Just to remind you mentally, this 60 inches goes on the top, always the big number on the top. This 16 inches, which is our radius, is always on the bottom in this case. All right, so this will give us 60 divided by 2 times pi times the 16 inches. And all of this as a value times 360. If you follow the steps correctly, you should get 214.9. So that's question number 1. Question number 2. Let's pull up a blank doc. Question number 2 is very similar. All right, in question number 2, you have a wheel, again, with a 32-inch radius. So, again, they're giving you the radius is 32 inches. They're saying that there is a mark. So if you imagine a wheel, they're saying there's a mark on the wheel, and the distance between this this area or these two marks is your arc length S. And they're telling you that that is 14 inches. Again, the formula we're using here reverts back to a modification of theta is equal to S over R. So keep it simple. So in our case, we would have 14 divided by 32 times 2 times 3.14, all of this times 360. So all of that times the 360. When the math is finished and you do all the steps, you should end up with 25.06, so rounded 25.1 because they want this in the decimal place. Okay. So that is question number 2. Okay, so let's pull up a blank doc. All right, so the next question is, a car is traveling 34 miles per hour. If its tires have a diameter of 26 inches, how fast are the car's tires turning? And then it does say express the answer in revolutions per minute. So taking down what is given to us, we have the car speed at 34 miles per hour. They're telling us the diameter is equal to 26 inches. And therefore, obviously, the radius is 13 inches. We need that information. Another conversion for this that you need to remember is that in 1 mile, we have 63,360 inches, because the question is asking for this in inches. We're using inches right here. Also, a very basic conversion you need to remember is that 1 hour is equivalent to 60 minutes. And we will need that as well. So we start the process with, let me go to draw, with 34 miles per hour times 63,360 inches in 1 mile. And we're dividing that by 60 minutes. And that result is 35,904. And this is in inches per minute. Remember, this is minutes out here. Okay. That's your step 1 in a sense. Step 2 is we take the 35,904 inches per minute, and we're going to divide that by 13, which is our radius. And this results in 2,761.8. And this is our angular value. We divide that by 2 times pi. And this results in our answer, which is 439.75. Okay, so if you look at the steps, they're not that long. It feels like it takes an eternity to get to the answer, but it's not that long. So just remember, it's basically the miles per hour times the inches in a mile. So that's your step 1. And we're dividing it lastly by 60 minutes, which gives us this value. We then divide this value by the half of the diameter, so the radius. And so we get this value divided by, you get 2761.8 divided by 2 times pi. And so the result is 439.75. Okay, let's look at question 4. In question 4, we have the pickup truck is fitted with new tires, which have a diameter of 41 inches. How fast will it be moving if the wheels are turning at 415? So here's, again, the idea is we have a diameter of 41 inches. We have the revolutions per minute. So rev per minute given to us at 415. So 2 things we need to do. Remember, the radius is half of 41, so 20.5. That's our radius. And we're going to now, remember, we have to multiply this value, the 20.5. We have to multiply it and convert it so it's 1 mile divided by 63,360. And so if you do this, it becomes a very small value. You get, basically, you get 3.23, I think 548, if I wrote that correctly. In essence, you're taking this number and dividing it by this number. And remember, this is times 10 to the -4, which basically means if you follow my drawing here in blue, I'm going to take this decimal and we're going to move it 1, 2, 3, 4 spaces. So this is really 1, 2, 3 zeros in front, and then 3, 2, 3, 5, 4, 8. And that's assuming my decimals are correct, because I may have rounded that. Let me check it with a calculator. So we have 20.5. Yeah. 20.5 divided by 63,360. So you get 3.235. It's 479. 798, but I rounded it right here, so you should still get the same answer. You might be off by a decimal, worst case. We're now going to take angular speed and we're going to multiply the 415 times 2 pi times 60 minutes. And that is giving me, once I multiply these two values, let me see, I'm getting 50.50, it's either, I rounded it, so I did get 50.59. It should be maybe 6 something as well, I think, because of the rounding. Regardless, you can round it up to 51 miles per hour. So it's not that terrible a question. All right. Let's do another one. Now you have plenty of practice. The methods are not different. So as long as you practice, you should be fine. So in this one, number 5, they're talking about Pythagorean identity, where we have sine squared theta plus cosine squared theta equal to 1. And we have been given 2 square root of 2 over 3 for sine. So we need to square that. And whatever this is, I'm going to call it x squared. If you just remember, it's cosine squared equals 1. So if I multiply this times itself, I'm going to get 4 times 2, because remember the radical cancel. So really this is 8 over 9. Don't forget the square applies to this, and to this. And then this is plus some x squared equal to 1. What is interesting is you're going to subtract this. I'm going to subtract the 1, 8 over 9, and so 1 minus 8 over 9. And we end up with x squared is equal to 1/9. And if I take the square root of both sides, square root of 1 is 1, square root of 9 is 3. So x is equal to 1/3. And I believe that's your answer choice B. Okay, the next set of questions are cofunction questions. So if you remember the cofunctions, so we start with sine theta is equal to cosine of 90 degrees minus theta, or cosine theta. And remember, this is the type that they would ask you on the SAT. So cosine theta is equal to 90 degrees minus theta. And if I have tan theta, that's equal to cotan of, again, 90 degrees minus theta. The only change that you may observe in some of these is that instead of 90, they'll use pi over 2 if we're dealing with radian. So as this example, we have sine. So the question that they gave you is sine of pi over 18. So this is going to equal cosine pi over 2 minus pi over 18. All right, and so we need a common denominator. So this will be times 9. This will be times 9. So you end up with 8 pi over 18, and that reduces. If I divide it by 2, top and bottom, I get 4 pi over 9. Okay, same thing applies to the 10. So let me do 10 of pi over 17. This is equivalent to cotan of pi over 2 minus pi over 17. Now this is a weird one because the denominator is going to be 34. So you get cotan of 17 pi over 34 minus 2 pi over 34. The reason is I'm multiplying this by 2 top and bottom. That's why I get 2 pi over 34. And I'm multiplying this by 17 top and bottom. So final answer here, 17 pi minus 2 pi is 15 pi over 34. So I believe that answer is D. I'm sorry, not D. It's A. My apologies, A. Because it's a cotan. So final answer, cotan, 15 pi over 34. All right, let me get you the last one here. And like I said, I'm recording these 10 at a time, so bear with me. And yes, we're taking our time. This is cosecant, secant. So this is cosecant pi over 10. This is equal to, or 10, this is equal to secant pi over 2 minus pi over 10. If I multiply this by 5 top and bottom, I get secant of 4 pi over 10, and that reduces to secant 2 pi over 5 if you reduce it. Okay, so that's that one. I believe we're on number, this is number 8. This is number 9. Number 9, they give you the tan theta equal to 13.2894. And I'm asking you, when you do this question, let me look at my notes real quick because I wrote myself a note. Make sure that your mode is in radian mode. Key, pay attention, mode is the key here. So you're going to use tan inverse and you're going to put in 13.2894. Once again, make sure you're in radian mode. Okay, very important. Oh, let me see if we get the yellow marker up here. Mode, muy importante. Be in radian mode. If you're in the wrong mode, the answer will not work. So use the radian. You should get 1.496 radian. So don't fall asleep while you're doing this review. I know I'm being very slow and purposefully diligent. Okay, we're looking at number 10. Let's see, I can pop this down a little bit. The radio transmission question. So this question sometimes tends to make people a little nutty. My suggestion is the guide wire is cutting this 140-foot wire. So this is 8, not this is the height, not the guide wire. So this is 132. The total of this is 140. And we know that because they're telling us. This is your 90 degree. And the way the question is worded is, and the reason why the 8 is up here as a reduction from 140 to give you 132 is it is attached 8 feet from the top. So we're, in a sense, going down 8 feet, if that helps, from the 140. And it makes an angle of 25 degrees with the ground. They want us to do this to the 10th of the foot. So if this is 132, and we're looking for X, we're looking at this angle here. This is 25 degrees. So if I do sine of 25 degrees, I'm going to go 132 over X. So 132 over sine 25 degrees. And in this case, you have to go back to degree mode. So your mode is another, once yet again, a key. And you should get 312. I want to go with 0.34. So let me check the math. And by the way, in your calculator, when you input it, I would do 132. And I would do, here's the division sign, then parentheses. I would separate it with a parentheses and go from there. Make sure I'm in degree mode. So in my case, I'm actually in radian mode, which gave me a negative 900 something. So let me clear it out again. So 132 divide sine of 25. And you get 312 point, technically it's 338, but they just want a 1/10, but we're good there. All right, I'm going to stop here. Like I said, 1 through 10. I'm going to do 11 through 20 next.